Welcome back. While playing with Visual Go, did you notice a problem with binary search trees? If not, let me demonstrate something to you. Let's say I keep inserting here. Let's say 86. And then while that's going, I'll also insert 90. And finally, I'll insert 99. All right, what is the problem with this? Well, you can imagine a situation where we have this really unbalanced binary search tree where all the nodes just keep getting added to the right, to the right, to the right, to the right. If we imagine that we didn't even have this section, this all of a sudden turns into a linked list where we're just looping through every single node. This is a big problem that comes with binary search trees. That is, you can have balanced search trees, like the one right here that gives us this log n performance, but then also have unbalanced ones, where it sort of turns into a long linked list, where instead of being able to do the log n operations, you now have to loop through every single node, and lookup and searches become O of n, or linear time. And you even saw in our Visual Go demonstration how slow it took to insert items because it had to loop through so many things. One of the keys that you'll have to remember, and this is a question that you might get asked in interviews, is why an unbalanced binary search tree is bad. And I hope this demonstrates why it's not a good idea. Ideally, we want to balance our search trees so that we can have this performance optimization. If we go to our Big O cheat sheet, we see that with binary search trees, that we have O log of n for most things, which is average. But when it comes to worst case, when we have an unbalanced tree, that all operations are O of n, or linear time. So you might be asking yourself, how do you balance a tree? And luckily for us, there's algorithms that help us do that. It is really advanced, and we will talk about it after we build our own tree and some of the options that we have. For example, we have things like AVL trees and red-black trees that allow us to make sure that our binary search tree is going to be balanced. Luckily for us, they're built in most programming languages, and in interview questions, they won't really ask you to balance a binary search tree because, well, it can get pretty complicated and time-consuming, and interviews usually don't have enough time to get you to do that. The idea is to be able to talk about it and know that there are ways to balance a search tree and be able to talk about the trade-offs just like we did. Now, we're going to talk about these two ways of balancing the search tree in an upcoming video. But for now, let's just focus on the basics. In the next video, I want to talk about the pros and cons of using something like a binary search tree, and then finally implement our own. I'll see you in the next one. Bye-bye.